Alrighty, welcome everyone to chapter 16 of the ggplot2 book. We are going to be learning about faceting today. So we're going to talk about the two different types of facets, facet wrap and facet grid, as well as controlling some of the functionality in one or both of those, and some examples of ways you might want to deal with peculiarities of faceting or dealing with data. So faceting basically breaks down a data set into multiple plots that show different subsets of the data. This is often plotting the same variable in each plot, but just like different categories of the variable or different subsets of that variable. So, compare it, the one that I would use would be like comparing growth across multiple individuals. So you'd have age and then body mass on the X and Y axis respectively, but then you would just have individual, like some sort of individual identifier across the different facets. There's technically three types of faceting functions, but really there's only two. The first is facet null, which is there is no facet. So it's not really a faceting function, although it is actually a function that you can call. So this is a single plot. This is the default. And then if you want to actually add additional faceting to your plot, you would use one of facet wrap, which wraps essentially a one-dimensional ribbon of panels into a two-dimensional grid. Uh, and or you would use facet grid, which produces a two-dimensional grid of panels where each of the dimensions, so the rows and columns, are defined by variables.
Oh, Ashley, are
Yeah.
you sharing your slides? Because right now I'm seeing the chapter, not the slides.
Oh, yep. I am.
Okay. I'm following along. I saw the
It
chapters,
was
so
just like a random page. I think it's because I clicked the wrong thing. Okay, is this slides?
you got it. There it is.
Okay. All right, so at the bottom of the screen there you see an example of facet grid and facet wrap on where basically in facet wrap you only need one argument and that's whatever variable you're faceting by. And then in facet grid you need two arguments, sort of, although we'll talk about how to actually call facet grid later. So facet wrap is very useful if you have a single variable with many levels and you want to arrange the plots in a spatially efficient way. Um, this would be like the example I said earlier, like if you have multiple individuals within a study. There are a number of different useful arguments in facet wrap that the authors of the ggplot book call out, although there are other arguments that you can look up in the help file. So ncol and nrow control how many columns or rows there are respectively. You only need to set one of these, and then the other one will be basically calculated depending on the length of the data. As table controls whether the facets are laid out in table format, where the highest values are at the bottom right, or as in like plot format, where the highest values are at the top right. And this sort of confused me at first, but I'll when we get to the
Mhm.
examples, I'll sort of like point out how it works. And then dir or direction controls the direction of the wrap, so H for horizontal and V for vertical. So if we take our uh, MPG, our altered MPG data set, that's like constricted is the word that's coming to mind. It's not the word I want though. That is constricted so that our plots don't get super unwieldy. We can first start by controlling the number of columns, and here we have ncol equals 3. And basically what this is saying is I want 3 columns. However many data or however many classes we have, just make them fit into 3 columns, and then uh, they'll fill 3 columns, go into a new row, fill 3 columns, go into a new row. If we had 7 classes, for example, we would get another row here with just one facet, one plot in it. We can also set as table is false to get this fun effect where instead of going from the lowest value in the top left to the highest value of class in the bottom right, it goes in from the lowest value in the bottom left to the highest value in the top right. Um, So the reason why they call this as plot-like is because you're basically going from 0 to 1, for example, so 0 in the bottom left corner and 1 in the top left and top right corner. This particular data set makes that not super clear because it's sorting the values alphabetically. Um, so that makes it a little bit harder to
Yeah,
wrap your brain around. But basically, it fills the bottom row first and then goes to the next row on top of that and then the next row on top of that. Does that all sort of make sense?
yeah, that makes sense. It was confusing because like when I was playing around with the code, it was like it was just changing the different or the positioning of the different categories, but that makes sense that it's basing it on the values and then what you have for as.table is going to change where is the highest value, where the lowest value is. But like you said, this data set makes it challenging because it's doing it by alphabetical order, not like numeric order, right? Am I understanding that
Yeah.
correctly?
Yeah.
Okay.
I mean, I'm assuming it's probably going in index order, but with this data set, like that's just alphabetical order. Um,
That's one of my pet peeves about ggplot and about the tidyverse in general, where they'll have these arguments and they're like, oh, let's name it this thing because it's like an analogy for
yeah.
how, which like makes sense to the programmer, I'm sure. The reference doesn't always make sense to other people. Like table versus plot, I feel like that's not that explanatory. Why couldn't they just do equals reverse or something? Like they keep doing stuff like this.
Yeah. Or even just like top down, like
Yeah,
or from top equals true or from top equals false or something like that. Because yeah, definitely top down versus bottom up makes way more sense to me. We can also, of course, specify the number of rows we want versus the number of columns. In this case, we said we want 3 rows, and ggplot will automatically take your number of classes and make sure that it fits into 3 rows. So in this case, we would again have like a bottom row with only one uh, column or one plot in the one column with a plot. And then we can also change the direction in which the plots start filling. So by default, this is horizontal, where you would go compact to mid-size on the top row, minivan to pick up on the next row, et cetera, et cetera. If you go in the vertical direction, you go from lowest index number on the top um, down the column through the index numbers, then to the next column, rather than filling a row and then going to the next row. We then have facet grid, which takes its argument for how to fill it in the format of a formula. So a y uh, tilde x layout. And this lays out plots in a two-dimensional grid. Um, I think this can be particularly useful to compare across combinations of variables. So if you have 2 variables and you want to take all of the possible combinations of these, that's the sort of like use case that I was thinking of. Although if anybody else has other use cases where they've used facet grid, I would love to hear them.
A good example would be like comparing demographics on like a specific trend.
Hmm.
So being able to align it horizontally like this, you would be able to see like certain trends for certain categories was really nice. And then that not only gives you the comparison of the trend, but it also gives you comparison across the groups.
Yeah.
Especially
Yeah.
if you like freeze the y axis, it really helps.
Yeah. Yeah, I guess this is also probably a a simpler in terms of like ease of coding way to put all of your plots in a row or all of your plots in a single column because you don't have to like be like how many different categories or how many different factors are there and things like that. You can just be like, nope, just put all of the classes in a row. All right, so basically this means that there's three different sort of uh, formulas that or three different sort of types that your formula will take. This is one where you only specify the x variable and then you put a y or a dot in the y position. This puts everything into a single row. So here we're taking the number of cylinders and just plotting it on a row. We can also do the opposite, so we can take the drive class and put that as the y variable. So we have a column with all of the different drive classes. And then we can add those two together. And what we'll get is a combination of the two variables. So in the top left plot here, we would have um, any car that has four cylinders and has a four-wheel drive class. Yes, it's four-wheel drive class. Then we'd have six cylinders, four-wheel drive, eight cylinders, four-wheel drive, four cylinders, forward wheel drive, front wheel drive, front wheel drive. That's the I don't drive, so this is exceptionally hard for me. I'm like, what is a car? What's cool is that you can also use multiple variables in the rows and columns, and this essentially works additively. So if you want two variables in the y position, you do a plus b, and then you also wanted two variables in the x position, you would do c plus d. So any variables that are specified on the rows and columns will be crossed. So you'll get all combinations of whatever it is that you put in the two different sides. So I made an example here where I took our example above where we have uh, the drive and the number of cylinders, and I added the class as our X variable. So here we have four-cylinder compacts, four-cylinder midsize, four-cylinder minivan, all crossed with four-wheel drive. And then we have, same with our six-cylinder, with our eight-cylinder, etc. So this will basically just create more individual plots within your faceting system that fine tune your comparisons. Did you
I
want me to
think
go
with
back?
that, no, with that example, it just seems like I saw that. I'm just making a comment. It's like I saw that example and I was like, I don't know if it would be a very specific use case for that, mainly because it seems like it's slicing the data to a point where, at least the data that I work with, that this would slice it to a point where a lot of these would be empty. So, I mean, a
Yeah.
facet grid, even just facet grid with two variables in itself already kind of like makes it a lot of those like places sparse for the data that I work with. So when I saw this, I was like, whoa, you have to have a lot of data with a lot of categories that you can slice and actually get a useful plot out. But that was just
Yeah.
my perspective of, but you have the functionality to do it, so it's there.
Yeah. Yeah, I was trying to think of like cases where I would want to do this. And um I mean I could definitely yeah, I know there are cases where I would want to do this potentially, but I can't my brain is too tired to actually think of them. And I think yeah, they'd be very specific use cases.
One thing that I was thinking, because I think you can do like, and this is going beyond our conversation, but like, and I'm being very US centric right now, but like you could split it geographically. So there's like a faceting system that allows you to split it by state. So I wonder if there is a way to do this same kind of concept with like state and county, you know? I don't know if we really want to talk about states and counties today,
Yeah.
but I was just thinking that like, you know, that might be a place where you would have enough data and enough place to like actually split to that point. I don't know. I've seen that before where people have those like visualizations where the United States is split up by states. Again, I'm being very use centric. So, but like that's like the facet itself, and then it has a plot for
Yeah.
every single state. But
Yeah, I mean, I could see like uh, coming from my own data, like if you wanted to compare like males and females of a species, and then you wanted um to look at like both whatever subspecies they're part of, but also like what climate they're being raised in, or like something like that,
mm,
where you have multiple factors that are influencing the data, and you just want a way to visualize like all of those factors. Um,
mm,
Although, like, I think the question then becomes like, is there a better, more concise way to visualize that? Alrighty. So, the scales parameter is in both facet wrap and facet grid and can be used to control whether the position scales are fixed, so they're the same in all panels, or if they're free, so allowed to vary between panels. So you can have both fixed, you can have free X only, free Y only, or both free. Just to give an example here, the default is fixed scales. So if we take our city mileage versus highway mileage, plot them with an AB line, which the documentation wasn't 100% clear, but I think geom AB line, if you provide no arguments for it, it defaults to intercept of 0 and slope of 1. That's what it seems like from here, but if anybody knows like anything about this, then do let me know. Um, Anyways, we can see this is basically the default if we plot those two. If we then give our scales free rein, um, it starts to look like this. So what we can see is that we now have a different X and a different Y axis, so different scales for each of our little facet plots. In this case, we're able to see that we are able to see that we have basically like a very similar slope between the two, but the range of values is different. And I'm really sorry, but my vet is calling me, so I'm going to have to mute for a second.
So maybe Ashley's going to talk about this, but just to fill the time, I often, for some reason, end up finding myself in the situation where I need scales equals fixed with facet grid, but I, for whatever reason, want the grid lines, like the X and Y axes, to show up on all the plots, because by default they don't for facet grid. I think they do for facet wrap. Maybe I'm wrong about that. Maybe they don't for facet wrap. But and it turns out there's no way to do that automatically in the facet functions, because the whole point of facet grid is like you have shared X and Y axes that are like aligned in a certain way, and they just don't have functionality to visualize repeated axes if you don't need them. And so there is a package that I'm now forgetting the name of and obviously can't look up, but there's a function called like facet wrap or something. It might be like in the lemon package. It's in some package with a weird name. And I've used that a couple times when I want facet grid, but I would just like to repeat the axes each time. So just FYI, that if anybody stumbles upon that use case.
Cool. I missed the beginning of that, but I think I know what the gist was anyways.
I'll find
Um,
the package and I'll send you guys that info in the chat later.
Sounds good. Oh right. So sorry about that. In the most shocking turn of events ever, the vet is running like ahead of schedule. So they were like, "Do you want to cut? Do you want us to do the appointment earlier?" And I was like, "No." Um, all right. So free scales um, don't seem super helpful in this example that we used up here, but they actually can be really useful when comparing something like a time series where you have multiple variables measured on different scales and you want to compare those variables across time. So here we take an economics data set, make it into long form, which is like, I was like, what? Making data long? Why would you ever do that? It makes sense when you do the thing, but it was like shocking, pearl clutching. Um, and then what we can do is we can wrap this economics data on our different variables. So, like population, unemployment. I don't remember what a bunch of these variables actually mean. And in this case, we keep our X scale fixed so that we're making sure that we compare across, like compare 1990 with 1990 across all of the different scales. But we allow our Y scale to be free so that we can have very, very, very different values. So like, 15 as our max versus 325,000, or is that 3 million? That's 3,250,000. Wait, no, 325,000. Um, so yeah, this was definitely like a good example, I think, of, cases when you would actually want to make um free scales. Not that I'm sure that it's actually that unusual, just not something that I've had to do a lot of.
A lot of the times that I use like free Y is time series stuff.
That
It
makes a
just
lot of
is.
sense.
Like any time that I do a time series that has different categories that split up some trend, it's always usually free Y. I mean, I guess it depends on the context and what you're looking at, but like some of the
Yeah.
metrics that I use are just in the variables that I have. When you split them, there's just like wide variation. And then if you keep it like fixed, what happens is like if you keep them fixed, basically what happens is you'll have one line with a lot of like ups and downs, but then the one will just be flat
Yeah.
and you can't
Yeah.
actually see the variation in it. So it usually pops up in time series when I have to do that.
That makes a lot of sense. So in addition to controlling um, our scale in facet grid, we actually have another parameter called space. And this takes the same values as scales, so fixed free or free X, free Y. But when space is free, each column or row, or so each, if you make the columns free, each column will have its width proportional to the range of the scale for that column. Um, Conversely, if you make the rows free, then each row will have its height proportional to the range of the scale of that column. And I did not really understand what was going on based off of just this description. So I did play around with the data that they provided just to hopefully illustrate the example. Although I was a little bit rushed, so I feel like I might be understanding this in real time a little bit. So we take our MPG2 data set. There's some reordering that happens here, which I think is just to make the variables plot out the way we want them. I haven't played around with like what happens if you don't do the reordering, but I think it's just to get the like the city mileage and the models. Yeah, well, like to get all the like models together, probably and all the manufacturers together. And then we can plot this. So if we plot it with no scale, no space argument, we get this. We get our our X labels on the left-hand side overlap completely. We get like points are cut off, and it's very, very ugly. And one thing to note is that the manufacturer, these are all spaced equally. So you have the same amount of space no matter what manufacturer you are and no matter what model you are. If we allow space only to vary, it actually looks exactly the same. If we allow scales only to vary, what we see is that we get a little bit of better separation in the models. We can actually tell what models are happening. And we see a sort of like the basically a different number of grid lines depending on how many models there are. But the manufacturers are all taking up the same amount of space. If we have scales and space both free, we now have a nice grid where each model gets its own amount of space and the manufacturers are allowed to vary in size so that they only take up as much space as they need. They're not equidistant, equally spaced. So like Honda takes up way less space than Volkswagen. I think I would like to play around with this a little bit more to see how some of this is happening. I guess I know we're adding, so this is the manufacturer labels are coming from like the facet function. And I guess, yeah, and I guess this is being called up here. I'm not 100% sure yet what is going on that makes freeing this space only look exactly the same as if you did nothing at all.
So I can't see this, just going by what you said, but it seems like freeing the space only does something if the axes are allowed to vary, right? Because the
Mm,
space, the it changes the space according to the limits of the axis. And so if your axes are fixed, or if your
yes, if
axis
they're all in the same limit.
are effect, but if your axis is free, then it can change.
Yeah, I think part of what makes this particular example confusing is because the y-axis is a categorical variable. I I think I'm gonna try after we're done and after my cats have their vet visit. I think I'm gonna try maybe replicating this, but with a continuous variable to see what happens if you change. Yeah, I think the same thing will happen, but I think it'll be more clear what's happening if you do it with a continuous variable.
Probably.
Yeah. Have to ruminate on that a little bit more.
Yeah, because a continuous would have a range rather than like a specific number value.
Hmm.
When you were saying a different example, I was also thinking like I'm thinking that this might also be good for like a box plot or something like that, where it would be able to split it up and then it would be a little bit more clear than the actual points themselves. So I thought maybe a different geome rather than
Yeah.
geome point would maybe like show a little bit more utility of this.
Oh yeah,
But
maybe.
because then that would make sense. Like then you would have like equidistant for all the different distributions for the different manufacturer and model, and then whatever that is. And I think it would just clear it up a little bit more. So maybe a different geome would make this a little bit more clear on how useful it would be. But
Yeah.
Um, mm,
I mean, I think the end result looks nice.
yeah, it does.
Nice
Well, I
separation.
mean,
But
well, it also gives, sorry, I didn't mean to cut you off.
no, you're good.
No, I think like it's really nice too because you can see it also gives you comparisons across different manufacturers. So you can say like clearly Toyota and Dodge in this data set and even Volkswagen had more models within the data. So
Hmm.
it not only gives you comparisons about the gas mileage for each model, but then it gives you like comparisons of like how many models did a manufacturer have in this data set. So I think that's really nice too.
Yeah, I agree. So one thing that happens with faceting is if you add a map, or if you map a layer that doesn't contain a variable, ggplot is going to take whatever you supply it with and put it in every facet. So basically what this means is that missing faceting variables are treated like they have all values. So if you just like provide a point and then you have your data split up into female and male plots here, um, it's basically saying like, okay, this point that is red on the plot is both female and male. It just is like it's taking all values of whatever variable is being plotted in that particular facet. So in this example, we have three data points. We have basically the values 1 through 3 for X and Y, and we've assigned our first two values, our first 2 points, female as their gender, and our last point, male as the gender. We've also created a single point that has an X value of 2 and a Y value of 2. So we can plot our X and Y across genders. So we have our females on the left and our males on the right. And just as we would with the regular data, we've got like 2 female points, 1 male point. And we have this geom point, data equals df2. So that's our single x equals 2, y equals 2 point. We're giving it a color of red and a size of 2. And as we can see, because it has no gender classification, it is just assumed that it is both female and male and it's plotted in both plots.
So example, before we move on, and I wanted to kind of pick everybody's brain on this because this kind of goes with a question that I had come up the other day. So I like this functionality where it's going to take DF2 and just like automatically plot it in each facet. But I had somebody ask me a question about, okay, if you're faceting, say you wanted individual reference lines for every single plot or reference lines that are contingent with the data that's within each facet. So their thing was like, say you wanted to have like an average line for Y and X for each facet.
Mm.
Because like you could do it and the functionality forces you. So if you did like an AB line, it would put that AB line for all of these. But how would you, or H line, B line is what I'm thinking of. How would you do individual lines for individual facets? I didn't have an answer to that. I said, well, you're probably arranging plots and just create each individual plot and arrange it in some way using like patchwork. But I didn't know if there was like a ggplot2 way to do that. So I want to pick everybody's brain here.
Colin, can I ask you a clarifying question about that?
Sure.
Are you talking about when you say like a reference line, are you talking about something that's computed from the data, or are you talking about like a manually specified, like a line with its own parameters that's manually specified?
Yeah, in this case, it would probably be like, well, I could see it two ways, but more likely in this situation, it would be manually specified where you would, so like here's the example. So like I'll just talk about the specific example. So say you have multiple years worth of data,
Uh-huh.
2021, 22, 2023, right? And say that you wanted to calculate an average. Now that I'm speaking, this might be the right answer to this. But what you would basically have is that you would have an average for your Y and your X for that specific year. And
Oh,
the way that this person is doing this is they're doing it outside, they're making the calculation and adding a geom H line, V line, but their facet wrap, once you add that, it's going to add that line for each single facet rather than having like individual H lines for each. You see what I'm saying? I don't know if that answered your
Yeah, so
clarifying question, but
I've done this before, and what you have to do is make a second data frame that's a summary data frame that contains, like, you would take all your data, group by the same variable that you're faceting by, and then calculate the averages within each group. So then you have like your second data frame that's not the same as the original data frame that you're passing into the ggplot call. That's called, like, and that data frame contains the faceting variable, and it also contains the X and the Y, like whatever aesthetics are going to be needed to plot your line onto the plot. And then you do your geom H line or whatever you're doing with a new data argument to do data equals summary, or data equals, the name of that summary data frame. And then as long as the facet variable is present in that data frame, it should still obey the same, it should inherit the facet wrap specification, and it should put each point or line onto the correct facet.
Okay, that makes sense. That makes sense now because
You'll
you
have to
have the
check me on that.
facet.
I'm pretty sure I've done
It sounds like it will work because I mean you have the facet variable in there.
it. Right.
It should, yeah. I mean, I'll have to explore that. I'll have to explain this to somebody who's just getting started with ggplot, but I might just have to do it for him and be like, "This is how you do it." Learn what I did. So, but yeah, no, I
Yeah.
appreciate the input. I'm gonna look into that.
Awesome. All right. So one of the decisions that you have to make as a plot designer is when to use grouping versus when to use faceting. So when we're using faceting, by design, each group is going to be relatively far apart because they're each going to be in their own panel. I think I'm frozen. Oh no? Okay. Maybe I think maybe Kaya is frozen, and then Colin, you were like looking off into to the side, and you were very still, and I was like, oh no.
Oh, we just lost Kaya. No, I just a message popped up and I was checking it and I
No,
was reading it. So I
no
wasn't frozen.
worries.
You're still good.
It was just like the perfect, I guess, confluence of events. Um, okay, so faceting by design, each group is relatively far apart because they're each in their own panel, and there's not going to be any overlap between groups because they're in their own panel. This can be really helpful if the groups are overlapping a lot and you want to be able to isolate for the viewer like what's going on in each group, but it can make small differences between groups harder to see. On the other hand, when you're using aesthetics to differentiate groups, the groups are really close together and they might overlap, which can be annoying or make things difficult, but it can be easier to spot small differences. I'm not 100% sure I actually agree with this statement. This is how the authors framed it.
This was confusing to me because like I tried to do a couple of the exercises too, and they were talking about grouping, and I didn't necessarily understand what they meant by grouping. Is it just meaning that you're applying a variable to an aesthetic in your geom? Is that what they were saying? Like I didn't really totally understand what they meant by like grouping.
Yeah, I think this is more of a I think this might be like a poor choice of words because I think in both faceting and aesthetics, you are grouping. It's just how you represent the groups. Does that make
Hmm.
sense? Um,
Yeah, kind of. Like in this case here, let's just take this example here. We have X, Y, and Z.
yeah.
Where are we grouping? What is considered grouping in this plot, or is grouping even being applied here, according to how the
I
book
would
defines it?
I would say Z is the grouping, right? Because you have a
Would it be
group.
the color of Z?
Oh, yeah, okay, I see what you're saying. That's what I think my reading is that Z is our grouping, and then color is how we're representing the grouping. That's how I
Okay.
kind of see it, but I don't know if that's like correct or the what the ggplot team would want you to see it. Because I could also see an argument for color being the grouping and we're grouping by Z.
No, I think your interpretation is
Okay.
correct. We're using the variable Z to group our data because you
Yeah,
could
as
group it
our
by
grouping
another
variable.
variable, right? We're
Yeah.
only representing those groups by the color. So I guess the
Yeah.
point of this chapter, and you're probably going to get to it, is rather than doing the color, what we could do is just we're still grouping by Z, but we're representing that differently by using a facet.
Yeah. Yeah. So we've got here Z is represented as different colors on a single plot. And then here Z is represented both, well, in this case, it's represented both as different colors, but also different plots.
Mhm. Okay, that
Um,
makes sense. Because I'm just thinking about the exercise that tripped me up because it was like the diamonds data set. It was like something like, okay, display the distribution of price conditional on cut and caret. Try faceting by cut and grouping by caret. So when they say grouping, it's like grouping, but if you want to do grouping, it would you would have a representation of that, whether that be like color or symbol or whatever it may
yeah.
be.
Yeah. Yeah, that's kind of a confusing way to word the question, I think. Um, now
But
maybe
oh
this is,
god.
oh, sorry, go ahead.
Well, then the thing was that it's like try faceting by caret and grouping by cut, So it was like, okay, I guess that makes sense. Like facet, you would facet by caret, and then you would apply like cut to color. Okay, I think I answered my own question, but
Yeah,
um,
I do think that's poorly worded. I think I would say like try faceting by caret and coloring by cut and vice versa. Like I think that's how I would phrase it because yeah, because both of them are groupings to me.
mhm.
Yeah. Anyways, yeah, that is confusing. I also find like, and this could just be having a lot of experience with plots, but I actually find the small differences are easier to see in the faceted example than in the colored example, even though that's the opposite of what they say. Because I think it's much easier to see the differences in center between like A and C in this bottom graph here.
I mean, I think it's getting at some of like the Gestalt principles of
Yeah,
this, and so it's like I can't remember the exact principle that this is following, but yeah, it makes sense. This is a clear representation of the differences rather than like
yeah,
grouping it on the scatter plot. I agree with that.
yeah. But it's harder to see differences in like the X values in this
Mhm.
case. So it can be harder to I guess how I would reframe this is small differences are easier to see on both axes, or differences are easier to see on both axes if you do like everything together in one plot. Whereas if you facet, it can make difference, like it can emphasize differences on a single axis, but it makes differences on the other axes or the other axis more difficult to see.
Mhm.
Okay, I think that's how, yes, I think that's how my brain is interpreting all of this. That said, you can kind of like overcome these challenges by just thoughtfully annotating your data. So we can take this data set here, just leave everything black, but provide a colored mean for each group within each of the plots. And this sort of solves our problem where we can see the differences in the y-axis very clearly, but it's a lot harder to see the differences in the x-axis by
Mhm.
actually emphasizing that, like, oh no, like C is way over here in comparison with A. Another thing we can do is we can We can still facet, but we can put all of our data points in each panel and then only color or only signify our focal data in some sort of obvious way. So we could plot all of our data in gray in all of the facets and then emphasize our focal group with color, which I quite like this. I would probably use like an additional way in addition to color to emphasize the groups, like maybe making the points bigger or a different shape or something like that. But
Mhm. Yeah, I like this one.
it feels like this is like I obviously you're not trying to hide anything in any of these examples, but it feels like this is the most like truthful with what the data is. It's the most representative of the entire picture.
Yeah, absolutely. I like this one. It's kind of like bee swarm plots. I know we're kind of faceting, but like
Hmm.
it's kind of like bee swarm plots where you have a categorical on your X, a continuous on your Y, but then you're still using like the dots with some jitter to
Yeah.
like show it. I think those plots are really interesting, but
Yeah. Now trickiness comes in if you want to facet on continuous variables. And basically what this means is you must first discretize them by binning them. Uh, ggplot provides different helper functions for binning. So we've got cut interval, cut width, and cut number. So cut interval, for cut interval, you provide an n, so you provide a number of bins, and it'll cut the data into bins, however many bins of the same length. Um, cut width divides the data into bins with a specified width. So let's say you want 5, that can be your width. Cut number divides the data into uh, n bins, which should each contain approximately the same number of points. So, um, so cut interval and cut number are different in terms of in both of them you're supplying the number of bins, but how they cut up the data is differently. So in cut interval, they will split that whatever your data range is into equal length bins, whereas in cut number, it'll take the number of data points and will split those equally. Now because faceting does not evaluate functions, you actually have to create a new variable containing your bin data in order to actually run this. So that's what's happening at like the top of this code here is we're making new variables for width bins, interval bins, and number bins. Um, and then in the plot here, we're just showing or we're gonna, no, we're just showing the width bins. So those are uh however many bins, 5 bins? Yeah, 5 bins cut into one into lengths of one, sizes of one. One what? What are we plotting? One city mile age. It's a very
yeah,
like
something like that.
unintuitive way to frame it.
So per gallon displacement. Is that what we're doing? Cut number. So you have your mileage on, you have, oh, so you have city mileage, highway
Yeah.
mileage, and then what you're
Oh,
splitting
and
by.
yeah, so we're taking our engine displacement. Is that it? Engine displacement? We're taking
Yep.
displacement and cutting it into 1 liter bins, gallon bins.
I'm not sure what the exact measurement is. I know it's representation of the size of the cylinder. I could
Yeah.
look it up. I'm not sure the exact measurement, but I'm sure, but yeah, it's like, it's the way I understand it,
It's a
like the size of the
volumetric
engine.
measurement, I think, right?
That's it. Yeah, because it's like how big the cylinder is. So like,
Yeah.
that's got me interested. It is in liters. Yep. So
Okay.
engine displacement in liters. So it is a volume measurement. Yep.
Okay.
Hmm.
Alrighty, so that's actually the end of the chapter. Um, and it is exactly 1 o'clock. So good timing, go team.
Yeah. Excellent. Good work. Excellent work.
Bearing with me, and thanks, Ashley. That was interesting. I learned some new things about faceting.
Yeah, no problem. I also learned new things about faceting.
Faceting is fabulous.
Faceting is fascinating.
Ooh, that's a good one. That's a good one.
All right, I have
It's a
to
good
go.
one.
I'll see you guys next week.
All
Yep.
right,
Really
see ya,
appreciate your work,
Kaya.
Ashley.
Yeah, no
Bye.
problem. I'll see you guys next week.
All right. See ya. Bye.